Hello, my name is Ferdinand, and in this video, I'm going to show you how to do the Scheffe test or the post-hoc analysis for one-way analysis of variance in Microsoft Excel. So, the chip test is just one of the post-hoc analysis that we could do in Microsoft Excel. If you want this test to be reliable, you need to make sure that you have an equal sample size, though it could also be used for equal sample sizes. And in this discussion, we will be using f sub s as the representation for the test value. And it is equal to the difference between the means of the two groups that you are comparing quantities squared divided by the square variance, or the variance of the within group times 1 over n sub 1, which is the sample size for the first group, and n sub 2 here represents the same size of the second group. And if you want to get the critical value for the Scheffe test, we just need to multiply the degrees of freedom for between groups times the CV, or the critical value of the F test. Okay, how about we use our previous example? Okay, we're going to use an example about one-way analysis of variance in Excel. So here, a researcher wishes to see whether there is a difference in the weight gains of athletes following one of these three special diets. So the first group took a diet A, the second group took diet B, and the third group took diet C. Now, after 6 weeks, their weight gains in pounds were recorded. And here's our data. Now, since we are comparing three means of individual groups, therefore, we need to use the one-way analysis of variance. So, by going to the data ribbon, data analysis, we will choose another single factor, and of our course, input ranges, this one. Then, labels for the first row, our alpha level is 0.05, and the output range will be placed here. And we have now our analysis of variance table. Now we can see from this table that the test value is greater than the critical value, and the p-value is less than 0.5. So therefore, we need to reject the null hypothesis. Rejecting the null hypothesis tells us that there is a statistically significant difference between the mean weight gains of athletes following one of these three special diets. So since the null hypothesis was rejected, we need to do post-hoc analysis. And here we can see that the sample size for each group are not equal. So therefore, we can use that Scheffe test to perform the Scheffe tests in Microsoft Excel. We need to prepare this table containing the pairwise comparison here. We are comparing diet A from diet B. We can also compare diet A from diet C, and diet B from diet C, and for computation of this formula, or for this value, or for the CVA, I divided our computation into three columns for the numerator, which is the difference or the square of the difference between the two means of each diet. And for this column, I have the FS denominator, which is the mean square variance within groups times this. Okay, so here we have the final value, which is f sub s. Now let's start with this row comparing diet A and diet B for the numerator. All we need to do is to type equal sign, then open parenthesis, get the difference of the means of A and B. We can see here that the mean for diet A and diet B is 5. So we need to subtract that 5 with this mean 10.17 for diet B, and then close parenthesis square this value, because in the formula we need to square the difference of these two means. So press equal sign, then we can have 26.96. Let's do this with the remaining cells. We have here diet A and diet C, so we need to subtract the mean of diet A, which is 5 minus the average, which is 4 plus 1 over the sample size for diet B, which is in this case is 6. So close this one, and we'll have 2.72 doing this for the remaining cells. We'll have A and C, we have 6.53 again, times this A and C, so 1 over A, and then the count for C is also 4. Then the last one is 6.53 times the count for diet B, and 1 over 6 plus 1 over 4. So notice that I just typed the specific values here instead of choosing the values. So anyway, we'll have the same result, and since we have the numerator and denominator, all we need to do is to divide these values, divide the numerator, which is this one, and the denominator, which is this part. So anyways, the critical value of the F test in the ANOVA summary table, the F critical is 3.98, and the value is 7.96, and the psi value of is 9.81, which is greater than 7.96. So meaning there is a significant difference between diet A and diet B and diet C. I mean, while diet A and diet C has no significant difference because it's only 0.0.8. It's less than 17.96, but between diet B and C, there is a significant difference between because the chipset test is 11.8 and it's greater than the critical value, which is 7.96. And that's all. Thank you.